we started process and threads. That is the next chapter. Okay. Under the process and thread, we saw what is process. Process is a independent executable entity. Okay. It is an independent executable entity, or otherwise we can say it is a program on execution. Okay. Or we can say a process is an executing instance of an application. If you take any application, for example, you are starting the paint application. Okay. So when you when you click and start the paint application, there will be a process created. And inside the paint, assume that you already saved one file. Okay, so that you're opening. Okay, so at that time, another process will be created. Okay, so here I'm not, there is another concept called thread. Okay, some of the systems support multi-threading. Advanced systems support multi-threading. Okay, so that time within the application, I said no, the second process will be created. That will be a thread. That will not be a process. Okay, so that we will discuss when we will discuss about the threads. Now you have to understand what is process. Process is a executable entity of a program, or a process is a executing instance. Now currently it is getting executed. Okay, so executing instance of an application. A process is an executing instance of an application. What is the meaning here? For example, you take any application. As I said, paint is application. In that, when you start a paint application, after you started, you are opening what? You are opening the already saved file. So in a paint application, there is a part inside the paint application that is opening the old file. Okay, so when you open the old file which you already saved, that is a instance of executing instance of that application. Okay, so that should be executed. Then only after you click the open the old file, it will come in front of you on the screen. No, so it should get executed. Okay, so that is called a process. Process is an executing instance of an application. An applications, any executing instance is called a process. Or we can say process is a program on execution. So any program on execution is called a process. Whatever it is, something should be now currently on execution. That is called a process. Okay, so this we saw, and then we discuss about when and all the process will be created in computing device, and when a process will be terminated, and then different states of process we discussed. Okay, we discuss about the different states of process. Okay, when a process will go from ready state to blocked state, any one of you? When a process will go from not ready state, executing, that means executing state to not this is also called executing state. Okay, when a process will move from running state to blocked state, any one of you? When a process will go from running state to blocked state? Yes. Students, make it fast. We have to go. We have to go to we have to see other concepts. Make it fast. Any one of you? Then I have.
When?
Yes. When? when a process, any process will go from running state to blocked state. A
When there
process
is
is
any
running.
irregularity or errors.
Sorry.
When there is any irregularity or errors.
Any input output request comes. You have to say like that. When a process is getting executed, that means CPU is currently using that process. But in between, the process is not completed its processing, but it is evicted and put it in a blocked state. What would be the reason? Because to proceed the execution or to proceed the running of the process, it does not have some data or some resource. Okay, so it can't proceed. It has to complete the that IO request, and then it has to come for execution. Okay, so something is missing. That means something which is required to proceed the execution is not available. That's why it is coming to blocked state. And being the blocked state, the IO request, why it came to blocked state, that will be fulfilled, and then it will go to ready state. It will not directly go to running state. Okay, from this questions will be asked. Okay, from the state frequently the question will be asked. Okay, so you have to study clearly. Okay, now already I said just what is address space. Whenever every process is created, operating system allocates some memory for that process. Okay, when the process is what, any program on execution. So when it is getting executed, it needs some memory. Okay, it actually needs some main memory. Okay, when any process is executed, anything is getting executed, it will use what? Main memory only. CPU will use main memory. Okay, so usually in the main memory, the address space for every process will be created. When it will be created, as soon as a process created, the address space also created. Okay, inside the address space there are many components. In that, one is called PCB, process control block. It is a table. Okay, so it's a table. Students, excuse me.
मशीन घुमाओ क्या?
Okay, so the address space will have process control block. Okay, that is one of the component in a address space. So each and every process will have its own address space. Okay, so like that, each and every process will have its PCB, process control block, which is called process table. Okay, now the process control block will be like this. Okay, PID, there is a, it is kind of index table. Okay, Now this index table will be there, it will not be there in address space of any of the addresses. It is commonly there in the memory, main memory. Okay. So for example, assume that there are 3 processes currently. So process ID will be 1, 2, 3. But in a real-time scenario, process ID will not be like this. Okay. It will be 008B, something like that. Okay. 1, 2, 3 will not be there. But anyway, unique ID will be given for each and every process which are currently which are currently there in a multi-processing system. Okay. So PID 1, the PCB block, okay, where actually the PCB block is located, okay, that address. And then 2 denotes what? Process 2. Okay, process 2 ka PCB block where it got saved, where it got stored. Okay, now this PCB address will be any one of the address of the address space. Can you understand? Where actually these are the PCB 1 and PCB 2, or where it will be inside the address space of the respective process. Okay. So address space will have range of addresses. In that, one of the address will be PCB address. Okay. So in simply inside the address space of a process, its process control block will be there. Okay. Now you see what will be there inside the process control block. Inside the process control block, there are many entities. I have put something which are important, only important. Okay. Pointer will be there. That pointer is a stack pointer. Okay. I am saying inside each and every PCB, what would be there? Okay. You should imagine, no, what would be the content of the PCB. See, all inside each and every PCB, the data related to that particular process will be there. Okay. Assume that this is a PCB of process 1. This is a PCB of process 2. Okay. So PCB of process 1 will have all the information about this process. Okay. PCB 2, that means process control block 2 will have all the information only about the process 2. Okay. So process, address space and PCB both are unique for each and every process. Okay. One process will not have more than one address spaces. Okay. One process will not have more than one number of PCBs. Okay. The same time, one PCB will not denote more than one number of processes. One PCB is for one process. Okay. Remember. So what will be there inside the PCB process control block? Pointer, that means the stack pointer of that process. For example, the process is getting executed. Okay, assume that process 1. Okay, which the process PID is 1, PID 1. So this denotes what? Process 1. So now process 1, assume that it is executed in the CPU and then it got evicted and then it stayed sometimes in a blocked state and it connected with IO devices and it fulfilled the task and again it is going to ready queue. Again the operating system, when a turn comes, it is picking up the process 1. Again it is coming to CPU. Okay. So whenever it comes to CPU, where it left, from where it left the execution, from there it has to start. Okay. So for that, to locate the memory, there will be a pointer. Okay. So that is called stack pointer. Okay. So what is the use of the stack pointer? Later the process, the same process, when it is coming to CPU, the CPU will be start from the stack pointer. Start the execution from the stack pointer. Okay. So that is the stack pointer. So the stack pointer will be there for each and every process that will be there inside the PC. And then process state. We know that every process will have any one of the states. What is that? Any one of the three states. Okay. What are those? Running, blocked, ready. Okay. So now currently this particular process, for example, this PID1, this particular process is there in which state? Whether it is in a ready state or blocked state, or currently it is in a running state. Okay, so the state will be there. That information will be there in the PCB of this particular process. And then process number, that is nothing but the PID, unique identification number of process. Okay, at any point of time in any multiprocessing system, the PID will not be repeated. Okay, for example, now currently there are 12 processes, in one multiprocessing system. This 12 current processes will have different, unique, that means different, different process ID. How in your class you have unique roll number. So when I am saying roll number 38, there will not be more than one there will not be more than one students will have roll number 38. Only one student will have roll number 38 in your batch. Okay. So like that, to identify the process in a multi-processing system, there is a unique, that means not repeated. Okay, unique process ID. Okay, so that is called process number. Okay, but listen here. Now currently there are 12 processes. Okay, in a multi-processing system. Assume that 2 processes completed its task. It got terminated. Now currently how many processes would be there in the system, multi-processing system? Only 10 processes. Okay. Now assume that one more process newly arriving. When process is terminated, of course, new process may also arrive, no? So new process comes, when new process comes, the operating system may allocate the process ID which it was allocated to the terminated process. Please understand. Please understand. It is like in your class, but that does not happen as per the roll number. In the record to roll number, that will not happen. But assume that in your class, one student got cancelled the admission. Okay. During the cancellation period, assume that first 2 months cancellation are allowed after you get the admission. Okay. So in that 2 months, there are many students getting cancelled. They are cancelling their admission. Okay. So after the 2 months, after we ensure there will not be any cancellation, what we are doing, we are rearranging completely the roll numbers. Okay. So what roll number we already allocated to cancelled student may be the roll number of new student. Okay. So that is the same thing here can also happen. When a process is terminated, that's it. Okay. When new process comes, the terminated process ID may be allocated to the new process. Okay. But whatever the case, at any point of time, 2 processes or more than one process will not have same process ID. Okay. Okay. Now this is process number. Process number means what? Process number, which is nothing but a process ID. Then program counter, we already know what is program counter. Okay. Program counter is also pointer like stack pointer, but which will point the address of the next instruction which is going to be executed in the CPU. Okay. So that is a program counter. One process may have more number of instructions. Okay. So program counter will point which is the instruction. The
Hello,
instruction. Yes.
Ma'am, paper will start at 12 now.
Yes, 12 o'clock.
Ma'am, it's 11:59.
11:59.
Yes, ma'am.
Okay. Chalo, we stop here. And after your test, I will continue. Okay. Okay. Let me just stop the recording.